He visited that is his best look. Stay frank. Oh, what's
Okay, guys, page 7 in your packet. Okay, I think we left off with 21 and 22 on page 7. Okay, so let me recap 21 because I think that was the last one that we did. So page 7, 21. We said that feels like there's too much going on at the beginning. I got that sine squared, I got that negative x. So the first thing I like to do is just get that square to be in a place where it doesn't feel like it's conflicting with what's going on. So the square is kind of like a shorthand way of saying that my entire expression is being squared. But the reason why you're going to see this written in this form a lot is because that way you can write it without having to use a set of parentheses. Okay, it's just it means that the entire expression is squared. But now I'm going to put them. We put them outside a set of parentheses so that it doesn't. So they can kind of focus in on what's going on inside. And we talked about how sine and cosine, one is odd, the other is even. The sine function is odd, which means that this negative x is just basically going to be the same thing as if I were to reflect that sine of x and put a negative out in front. So I'm basically just pulling that negative out in front because that's the property that is one of the identities that we practiced through yesterday. And then we did the same thing with cosine, but cosine is even, which means that the negative x just disappears. Okay, it's like x squared. Any negative number you put inside the x, that squared will make it go away. So cosine has that similar feature to it. So if I can get the negative to be pulled out in front for sine and the negative to disappear for cosine, now we can look at each individual term and then deal with that exponent accordingly. So negative times negative for sine becomes positive, so that becomes sine x squared. Cosine is positive already, so it will remain positive. And then I can put the squared back in its shorthand form. Sine squared plus cosine squared, we know that's equal to 1, so 21 was 1. Okay. All right, 22. Let's do 22, and then we'll do 23, and then we can start the next section. So 22, secant squared negative x minus tangent squared x. Let's get that squared out. It's not a set of parentheses, so we're not having to deal with too much at once. So I'm just going to rewrite it. Secant negative x quantity squared minus tangent x quantity squared. Now there's something that we can do with that secant and negative x, right? Secant and negative x, is that even or odd? Even, yeah. Cosine and secant are the only even functions. Those are the ones that where the negative disappears. And then all the other ones, right? There's 6 trig functions, 2 of them are even, which means that there are 4 that are odd. Okay, so that secant negative x, the negative disappears. So I'm just left with secant squared minus tangent squared. So secant squared minus tangent squared. If I rearrange one of my inequalities, what's secant squared minus tangent squared equal to? 1, right? If I subtract that tangent squared over, secant squared minus tangent squared equals to 1. All right, let's finish off with 23. So 23, tangent of pi over 2 minus x. Look on the previous page there. Tangent is basically this. We can, if I shifted it, it'll turn into a what? Cotangent. Yeah. Okay, so here's 23. Right, we know there's something special that we can do to clean this up. A substitute for this tangent of pi over 2 minus x is just cotangent of x. Okay, what do you see that we can do from here? Yes, eventually, but is there something that we can quickly do to, yeah, let's just take the cosecant out. But yeah, that, after we take the cosecant out, we can begin thinking, yeah, let's get these two to look more similar to each other. And the way that we can do that is if I can get sine and cosine to start appearing, then I can have an easier time combining, right? So cotangent is the same as cosine over sine, yeah. All over cosecant is same as 1 over sine. Got a complex fraction, but I know that I can flip that 1 over sine up to the top so that I can get that to disappear from the bottom and transfer it up here. You know, sine and sine goes away. So let's just look at that numerator here, cosine over sine times sine over 1. Anything that we can do there? Yeah, sine in the denominator, sine in the numerator. I'm just left with what? Just cosine, yeah. Okay, so today we're basically going to continue with this process. The problems will feel a little bit longer, but the strategies, we're going to kind of apply similar strategies in terms of we're just trying to get our messy expression from one form to a cleaner form. Okay. All right, so let's go to page 8. Okay, so number 1, it says tell whether or not, page 8. Okay, tell whether or not our function equals sine of x is an identity. So all we're trying to do is we're just trying to play with this to see if we can make this turn into sine of x. Okay, if we can make it turn to sine of x, then we know that the function is an identity, or that function equals sine of x is an identity. But if it doesn't, then we know it's not. Okay, so same thing that we did before. We're just trying to clean up that tangent and secant x to look like something else. So what's our strategy there? Similar to what we just did. Thank you.
I also need the packet this year.
Okay. Let's say do what? Yeah, let's rewrite it, right? Let's get the numerator denominator to look the same as each other. So let's get sine and cosine to begin showing up. Okay. Right, so tangent is the same as and then secant is the same as over cosine. So we can flip that denominator to the top. Cosine goes away. And then the numerator, that just turns into what? Sin x, and that matches what it's asking, right? Does the end result end up equal sin x? It does. So yes, it's not good. Okay, so let's talk about what we're trying to do here. So it says prove the following identities. We're not trying to solve for x, okay? It's not an equation in that sense. What we're doing is this, and sometimes we do go from right to left, but usually we go from left to right. So think of it as this, that we're starting here. And we're just going to play with the left side. Okay, we're just going to clean up, clean up, clean up. And then we know we've reached the end if we can make that left side look like the right side. So this is the end goal here. We know we're done when we can start on the left side. So just pretend like, you know, these are like how, well, imagine where we had two columns, right? One column was the problem, and then the right column was the one that we're trying to match up with. So imagine that this is on the right column, what we're trying to match up with, but it's already telling us what we want to reach, right? So this is, we know what our goal is, but we're not going to play with both sides. We're just going to start on the left side and just continue working. Okay, so our problem number 2 here, we're just going to work on trying to clean this up. So one thing I see is, well, what if I just got rid of the parentheses, right? What if I just distribute it through? Okay, so I'm going to distribute through and just see what I have after the parentheses are gone. Okay, actually, I'm going to do this. I'm going to just put on a separate sheet so I can have enough room to show you all my work. All right, so I'm just thinking, oh, well, if I just distribute, at least I can get rid of the parentheses, and then from there, I can begin looking to see what can happen next. Okay, so I've gotten it down to 2 terms, right? The parentheses are gone. My goal is 2 terms. So what can I do within each of these terms to maybe find ways to push things together? Yeah, get everything in terms of what? Sine and cosine, right? That way we can kind of match the parts a little bit easier. So I'm going to get that cotangent to show me a different version. So cotangent can be written as cosine over sine. Sine and cosine I can't do much with. I'll leave those alone. But tangent I can rewrite as sine over cosine. Now we can clean up within each fraction because there's that plus sign in between, which tells us that these are really individual problems, right? We don't have to worry about, you know, when cancel one, that's going to impact the other. So these are 2 separate problems. We can clean up individually and let's just see what happens. Okay, so here, what cleans up? Yeah, sine goes away. Yeah, I'm just left with cosine. Then what happens here? Sine x times cosine x times sine over cosine. If it helps, if you want to make them all fractions so you can kind of see numerator and denominator. Okay, what can we do? Cancel out the cosine, but do I cancel out the sines? No, they're both in the numerator, so I can merge it and turn it into what? Sine x squared, yeah. If you want to write it out that way, then it's going to be sine x squared, but we know that there's a shorthand way of writing it. We can put that 2 between the sine and the x, and it means the same thing. Okay, do we reach our end goal? Yes, so that's how we know when to stop. Okay, we stop when we can make the left side turn into the right side. And sometimes we have to, sometimes we don't know when we're on the right track, so we're just continually looking back and forth to see how we can get that left side to look like the right side. Okay, so any questions?
So ever gonna be a point where it's like try one strategy and it doesn't work, you try another strategy?
It is, yeah. So that is what some students find frustrating. It's like sometimes if you run into a dead end, you may have to kind of backtrack and try a different strategy to get the problem to mesh the way it wants to on the right side. Yeah, question.
I got it, but it's different. Like I didn't do the, I didn't solve it like this is the first.
Oh, you rewrote as sine and cosine first?
Yeah, like inside the.
That's fine. And they distribute later?
Yeah, but I got it.
That's fine. Yeah. So adding to that, there potentially could be multiple ways they can get to the answer. What you could also do is you could clean up the cotangent and tangent at the beginning, clean that up, and then distribute the sign through at the end, and you will get the same thing. So as long as you follow algebraic steps, you don't have to follow the same steps to the end. So there is some flexibility. Okay. Good. Yeah. So keep asking questions because there's a lot that is going to take time to kind of make, before we get comfortable. All right. So let's look at number 3. Again, I would say the rule of thumb is we can always start on the left side and let the right side be your goal. May come across some exceptions, but let's just let that be our default. Okay. So again, we're just playing with the left side here. Okay. We're not going to try to do anything. We're not trying to solve anything. We're not working. We're not going to be adding or subtracting from both sides of the equation. We're just working on the left side. Okay. So I want to get that left side to begin looking like a different form. So what's something obvious that we could do here? Yeah, let's just expand it out. Now, careful. Can I just distribute that squared and call it cosine squared minus sine squared? We got to do what? Got to write it out. Yeah, write it out twice. Because if you don't, then you're going to miss out on some terms because of the expanding process. Okay, now spend the time to distribute through to every term. There's going to be 4 terms that's going to come out of it. We may have some like terms, but we'll take it step by step. So I'll distribute the cosine through. Then I'll distribute the negative sign through. Cosine becomes cosine squared x. Okay, when I put 2 terms next to each other and multiply, the order doesn't matter. I mean, you can write it as cosine sine. I'm going to write it as sine cosine. Okay, distribute the sine through now. Okay, let's continue looking to see what we can do to clean this up here. What do you see? Is there anything else that we can add together?
Cosine squared x plus sine x
Equals 1. Okay, so that's good. There's a property that's waiting for us. How about the middle terms? Combine it right there like terms. So when I combine it, what does it become?
-2.
-2. Yeah, because there's 2 of them, right? And they're both minus signs. So and we have a property here, right? Like you said, sine squared plus cosine squared. I can just put them next to each other and turn it into what? Into 1. Okay, have we reached our goal?
Yeah.
Yes, right. As soon as you can get that left side to turn into the right side, you know you're good. You know that's when you can stop.
That's great. Is there ever a case where it's like once it both has to be equally to like simplify it?
No. So we're not going to work on both sides of the equation. Okay. So the right side you're going to leave alone, and you're just going to work on the left side to make, and then just work on the left side until the left side looks like the right side, and that's it. That's all. Because we're not solving, we're just verifying. So verifying just means it's like a proof where you have a beginning, and then you're told what the end is supposed to look like, and you have to fill in the gaps to get from the beginning to the end.
Whenever we want to exotic, like.
No. I won't give you one where you can't get to the right side. Okay, so you're always going to be able to work it through. Okay, so I'm gonna copy down number 4 here. We'll try number 4. Okay, so again, I'm just working on the left side of the equation. I'm trying to turn that left side after I put it through a different variations of forms, eventually to make it turn to the right side. So what do you think we can do on the left side to begin our process?
Sine and cosine.
Yeah, you see the right side in terms of sine and cosine, so that's a big hint, right? Well, I can quickly convert these to be in terms of sine and cosine, and then hopefully that will lead me towards where I need to go. Secant of x, we can write as okay, so what's nice about these two fractions? Right, they're right. We already have common denominator, so that's nice. We can just put them all, we can put them together. But we're not quite at the end, right? Not quite. Well, at least we have the sine and cosine, but the numerator denominator look a little different. So what can we do? Well, I'm looking at that cosine and I'm thinking, I'm going to try to create something out of nothing. Because remember, I can always, if I want to change the denominator, I can always change the denominator as long as I do the same thing to the numerator. Yeah, question?
Wait, why wouldn't it be squared again? If you're adding?
Yeah, just adding, right? It's like 1/2 plus 1/2, right? It just becomes 2/2. So when I add fractions, my denominator stays the same. So the strategy here is, what if I am able to get that cosine to turn into an identity? Okay. So what if I were to multiply the bottom by cosine x? Remember, I can do the same to the numerator and denominator. I'm not changing anything here. But what's the advantage here? If I get cosine and cosine to multiply together, that becomes what? Cosine squared. If cosine squared is available, then I have something to work with, right? I have an identity to give me some options. Okay, so I'm gonna distribute that cosine through the top, and I'll multiply that cosine to the bottom. Okay, and the way I know that is I'm looking, you know, like I don't see anything that I can reduce or cancel out. So maybe I can introduce and make something squared to give me something to work towards. Okay, sorry, I'm not going to distribute the numerator just yet. I'm gonna leave that numerator alone because maybe that sine x plus 1 is going to be helpful. Okay, so that cosine squared x, we have an identity that we can replace. We can rewrite cosine squared x as what? 1 minus sine squared. Okay. Okay, again, we can't cancel because the sine squared and sine are both attached to some other term by addition and subtraction. But there is something algebraic that we can do with this 1 minus sine squared x, and what's that? Factor difference of squares. Yeah. We can break them down into 1 and 1, sine and sine. Right? A squared minus b squared is a minus b times a plus b. So I'm just going to get that denominator to factor. Okay, so what does that turn into? 1 minus sine x times 1 plus sine x. Okay, what do you see? Right, the order is different, but 1 plus sine x, same thing as sine x plus 1, right? So that goes away nicely. Okay, have I reached my goal? Yes. All right, now, as soon as it looks like the right side, we know that's when we can stop. All right, number 5. Okay, we're never going to work on both sides of the equation, so we can't like cross multiply and try to get that to work. Okay, so we're only looking at the left side, and we're just continuing to work on left side, and we're trying to get that left side to be in terms of the right side. Okay, so secant squared minus 1 over sine theta. Anything stand out to begin the process here? Yeah, I see an identity, right? Secant squared minus 1. I can rearrange this second identity here. If I subtract 1 from both sides, secant squared minus 1 is the same thing as tangent squared. Thanks. Sine and cosine, right? Because I like to keep looking at my goal and see what's going on here. It looks like my goal is all in terms of sine, so I can begin to get that to happen, right? I know that tangent can be written in terms of sine and cosine. Complex fraction, so what can I do? Right, reciprocal, right? Let's bring that denominator to the top. I can always bring any denominator by taking the reciprocal and pushing it to the top. Sorry, 1 over sine theta. Okay, so this is what I have to work with now. Sine squared over cosine squared times 1 over sine theta. Any cleanup that you can see here? One of the signs can
One side can go away.
go away, right? I got 2 up here, I got 1 below. Any questions so far? Yeah. Say it again. The sine theta, that's on the denominator. Why would we multiply that by sine theta to get it? Because if I multiply by sine theta, then I'm left with sine squared theta. That feels like it's too much. It's good, because remember, if I divide by a number, right? Let's say I have 1/2 divided by 1/3. That's the same thing as multiplying by the reciprocal. That's what I'm doing. I'm flipping that denominator to the top, so that makes it easier for me to see how they relate to each other. Now we're getting close. Look at our goal and look at where we're at. Looks like my numerator is nice and clean, but my denominator, is there a way for me to get from cosine squared to be 1 minus sine squared? That's just identity, right? Cosine squared is 1 minus sine squared. I just have to make that jump using the identity. So if I recognize that identity, then I can just write that down. And okay, so similar to proofs, but you don't have to write a justification statement for everything that you do. You just have to show the steps. Okay, number 6. Okay, this gets a little messier here. Number 6. Thank you. Okay, so number 6, again, we're just working from the left side of the equation. We're not going to touch the right side. We're not going to add and subtract from both sides. Just the left side. Okay, so 1/1 minus cosine plus 1/1 plus cosine x. What do you think we can do here?
1 equals cosine squared minus cosine.
First, one of them comes on.
You do 1 minus.
We can't. Yeah, I mean, it feels like it's nice if I can just flip this in terms of secant, but
Cosine squared.
so when I see two separate fractions, what's the instinct that you think we can try to do? Combine it, right? If I have two fractions and if I can combine it, then I can have an easier chance to see what is happening, right? Because right now I have, my answer is only one term. I have two fractions, so let's try to merge the two fractions. But if I want to add two fractions together, what needs to happen? I got to have a common denominator, right? So think of this as one expression and this is another expression. So I need a common denominator that both can multiply into. What do you think is a common denominator that I can have that will be large enough for both of those to multiply into?
Can't you just multiply by -1? Make one of them subtract.
And then, but then if I do that, I get -1 plus cosine x. That's not the same thing as this. Right. Okay. So basically, if you're looking at the parentheses and you recognize that these are two completely basically different expressions, my common denominator is just I need both of them. Right. My common denominator needs to be large enough where both of them individually can be a part of. Okay, so now that we've established a common denominator, we need to balance each fraction. So what has changed from this old denominator to this new denominator? Right, so I need to add a 1 plus cosine x to get from this from the old denominator to new denominator. So that also tells me I need to balance it out. I also need to multiply the top by what's missing, 1 plus cosine x. Okay, so now 1 times 1 plus cosine x, just 1 plus cosine x. Okay, so second fraction. What's missing between this and this? Yeah, so that's exactly what I need to multiply the top by to get that balance. Okay, distribute that through. Okay, now what can I do? Yeah, add them together, right? Now I can, remember, if I have a common denominator, my denominator is just going to show up once. I can just add the top together. I see some students do this. They start canceling out. What's the issue here?
You just go back and forth.
Then you're back to where you started, right? Because you're forcing the situation to get the common denominator so they can merge them together. We don't want to start canceling out because then we're back to where we started. Let's. Oh, you mean multiply the denominator? Yes, that'll be our next step. But you can do two things at once if you like. But yeah, we're going to eventually probably get the denominator to merge together. Okay, so I'm going to add the top together first. My denominator, I just want to kind of show that we haven't changed it. My denominator is going to stay. So 1 plus cosine x plus 1 minus cosine x. Okay, so the numerator combines nicely. Do you see anything that goes away or cleans up nicely up top? Cosine x. And my 1's become 2. Okay, I'm looking back at my start. I'm getting closer, right? At least I got that 2 to show up. But my parentheses is not quite matching yet, but what can we do there in the denominator? We can expand, right? If we expand, maybe we can get something else to show up, get the parentheses to go away. Okay, so distribute the 1 through. Okay, what happens? Like terms, good. And you're just left with what? Minus cosine squared x. Okay, does that remind you of anything? Identity, right? 1 minus cosine squared x is an identity. If I can rearrange that identity, 1 minus cosine squared x equals sine squared x. Okay, I'm getting close. Sine squared is same thing as, or 1 over sine squared is same thing as cosecant squared, right? So if I just flip that sine squared up to the top, I can just turn it into cosecant squared because sine and cosecant are reciprocals of each other. If you want to see it more clearly, I can separate it, think of it as 2 times 1 over sine squared x. And we know that 1 over sine squared x is cosecant squared x. There we go. We have the right side achieved.
That's, it's like the, bottom left step. How'd you get there? 2 over 1 minus cosine x plus cosine x minus cosine squared x.
Okay, so you mean from here to here?
No, how'd you get from like how'd you get to the one on the bottom left?
Bottom left.
Like, how'd you get to that one?
Oh, okay, so I foiled it out. I expanded, distributed the parentheses through. Okay, number 7. Okay, I'm starting on the left side here. I want to try to decide how I want to kind of move through this problem. What about the right side kind of gives us a hint as to what we may want to do?
We're gonna use this like a 1.
Okay.
All squares.
Change the sign to cos, like.
Right. Good. So I see sine and cosine here, but I'm only going to end up with cosine. So maybe I can play with this sine square to get it to look like more like cosine. And we know we can convert from one to the other because, like you said, we have an identity to play with. So I'm looking at what I have. I'm beginning with, I'm looking at where I want to end up. So if I can find a way to get that sine square to look like something different, then maybe I can get everything in terms of cosine squared, right? So sine squared is the same as what? 1 minus cosine squared, right? I'm just rearranging my identity to get that sine squared to be something equivalent to it. Because it's not a plus, it's a minus. So a minus is not an identity, so we can't quite apply that. So I converted the sine squared to be 1 minus cosine squared. There's that minus cosine squared from the second term. And now, what do you see here? Combined like terms, what does that become? Okay, do we reach our goal? Yes.
You substitute the a for the x.
That's fine. Yeah, you can use any variable you want. I just copied what I saw. Okay, we're starting on the left side, trying to get it to look like the right side. Is there anything that stands out to you as something that we can try to do at the beginning? Okay, so I think there are multiple ways. Yeah, so if you want to convert to be in terms of sine and cosine, that's fine, but I want us to understand that eventually we do want to merge those two fractions together, right? So either we do it now in terms of tangent, or we can get in terms of sine and cosine. But I think with sine and cosine, then you got to deal with another complex fraction. So why don't we just get this tangent to come together as one fraction? And then once we have one fraction, then we can kind of just play with the numerator and denominator separately, rather than, I feel like dealing with two fractions, extending this a little bit longer makes it more complicated. So I'm going to force the second fraction to be a denominator of 1, right? I can always do that. If something is missing a denominator, I can always put a 1 underneath just to kind of get my fractions to kind of match up a bit. Okay, so I want to add two fractions together, which means I need what? Common denominator. What's my common denominator? Tangent B, right? Because one can go into tangent B can go into tangent B, and one can go into tangent B as well. Okay. Any balancing steps needed here? Well, the first one. No changes, so if there's no changes, then I'm just going to bring my numerator down. But the second one, there's a difference, right? I need to multiply 1 by tangent B to get tangent B. So that's what I need to multiply the top by. I need to balance that out. Okay, so tangent B times tangent B is tangent squared B. Now that I have a common denominator, I can do what? Put it together as one fraction. Remember, your denominator doesn't change. You're just going to put the numerators together. All right, we're not quite there yet, but does the top form help us out? Anything stand out to you? 1 plus tangent squared equals. Yeah, so we have an identity, right? So we're getting closer, right? We're able to get that secant to show up at least. Okay, what about now?
How do you turn this
Yeah,
tangent to cosine?
yeah. It does feel kind of strange to try to get this. So why don't we take an extra step? It may not be as efficient, but why don't we get this in terms of sine and cosine, merge things together, and then see if the sine and cosine can turn into secant and cosecant. Right, so let's just use, because right now it just feels like it's too much to try to think, how can I get tangent to look like secant? So what if I just get sine and cosine to show up, and then I can clean that up and then bring it back in terms of secant and cosecant. Because I know that secant and cosecant is just reciprocals of sine and cosine, so it's just one additional step. So secant squared can be written as 1 over what? Cosine. And then tangent can be written as sine over cosine. Okay, my denominator I can always flip to the top and put a multiplication sign between. So my denominator, I'm just flipping it and making a multiplication. Okay, so now this feels a little more familiar, right? What can I do to clean this up? Get one of the cosines to go away. Okay, so if I want to bring the cosine to the top, right? I'm getting close. 1 over cosine, the same thing as secant, and then 1 over sine, the same thing as cosecant, right? So if you want to write it this way and say 1 over cosine of b times 1 over sine of b, maybe that's a little bit cleaner for you to see. Oh, okay, that's cosecant, that's secant, cosecant. Okay, yeah, we're gonna just continue working with this. We'll pick this up on Monday. Okay, don't forget your phone.
Wait, how do you put a square bracket?
Oh, this right here?
Yeah, so like, is that what you'd be like multiply by itself? If you put it around?
So I'm balancing it. Right? So you're good with these two fractions. You're good with the denominator. You're good with the denominator.
Yeah, but like how you get there.
So, or you're good with this fraction, there's no changes here. So I'm not going to stay at home.
Yes.
But here, what has changed from here to here?
Well, it's in the.
Right, so in order to get from 1 to tangent B, I gotta multiply by tangent B. Right?
Yeah.
So if I multiply the bottom by tangent B, I gotta multiply the top by tangent B.
Okay. Oh, that makes sense. Thank you. My bad, my bad.
Yeah, she's yelling at people on their phone call.
Yeah.